Hello friends, so today we will start with using how to use stereographic projection, okay, to plot a standard stereographic projection of different projection planes. Okay. So, before coming to that, there are some important points we should know or remember, okay. That is that any for any plane, okay, angle between a plane and its normal, okay. So, if this is a plane, this is a normal, okay, then that will always be, the angle will be always 90 degree, obviously that is why we call it as a normal to that plane, okay. So, the angle between a plane, suppose like this, and its normal, okay, that will always be 90 degree. And since we have already agreed that stereographic projection preserves the angular relationship, that means the angle between a pole, okay, which we have already projected, and a trace, which trace of a plane, which also we have projected on the equatorial plane. The angle between the pole and the trace of a plane will also be or projection of a trace of a plane will also be 90 degree. Okay. And if any plane P1 is perpendicular to another plane P2, okay. So, there can be condition like this. So, this is the one plane, okay, another plane is perpendicular to it, okay. Then the pole of P1 will lie on the trace of P2, okay. So, suppose if you take basically the normal of this and you take the normal of this, okay, this normal is going to lie in this plane, normal of this plane which is perpendicular to it will lie in this plane, okay. That means the pole of this plane will be lying on the trace of this plane, okay. That is what we are trying to say. So, mathematically how we can understand this is that the dot product of P1 and P2 should be 0. So, if P1 has the indexing as H1 K1 L1 and P2 has indexing as H2 K2 L2, if they are having a 90 degree angular relationship, then the dot product should be 0. Okay. So, that is what is shown here also. For any two planes, okay, I can always find out that what will be the angle between the two planes. So, if P1 is H1 K1 L1, P2 is H2 K2 L2, then I can find out the angle between these two planes by a relationship like this, which is true for cubic crystals. Okay. Obviously, if P1 and P2 are perpendicular, okay, then cos theta will be equal to 0. Okay. That is what we know already from trigonometry, and theta should be 90 degree. Okay. If that is true, if cos theta, if I make it 0 here, what will happen? This whole thing will be 0, and H1 H2 plus K1 K2 plus L1 L2 should be 0. Okay. That is what I have written it here, and that is what we call as Wey's zone law also, okay, that H2 K2 L2 is in the zone of H1 K1 L1, okay, and their dot product should come as 0. And that also clarify that the pole of H2 K2 L2 plane, okay, will be lying on the trace of H1 K1 L1. Okay. Now, how to use the Wolf net which we have seen earlier, okay, to plot this standard stereographic projection. So, whenever you want to measure the angle, okay, once we know the angle, we know the two poles, okay, that should be measured when both the poles lie on a great circle. Okay. Why we want to measure only on great circle? Because only the great circles have their center and the center of the sphere coinciding. Okay. And that is why when you measure any angle on the great circle, it will be a true angle, okay, because both the centers are coinciding. So, if we want to measure angle between any two poles, okay, then we have to measure it on the great circle only. Okay. If not, suppose if there are two poles such that they are not falling on the great circle, okay, I can always rotate the Wolf net or my projection relative to each other. Okay. So, that is allowed, there is no harm in that. I can always do a relative motion between them, okay, and by doing that what I am trying to do is I am bringing both these poles on one of the great circle. Okay. And the third point is the trace of a plane will always lie at 90 degree to its pole. Okay. So, already we have discussed that the pole and trace will have a 90-degree relationship. Okay. So, if I want to find the trace of a particular plane, okay, projection of a trace of a particular plane, okay, if I have already a pole, okay, I can easily find out that what will be the trace, because I know that it will have a 90-degree relationship. Okay. So, again to do that, basically we will be rotating the projected pole relative to the Wolf net, okay, and how much rotation will be there till the pole fall on the equator of the Wolf net. Okay. So, I have to bring the pole on the equator of the our stratigraphic projection or of the Wolf net, and then trace the great circle which cuts the equator 90-degree from the pole. Okay. So, from language it may not be very clear to you right now, okay, but when we will do it, it will be clear to you that how I can use the Wolf net to find out the trace of a particular pole. Okay. So, first measuring the angle between the planes or poles, okay. Again you have a Wolf net here, okay, and suppose there are two poles like A and B. Okay. Now, fortunately A and B both are lying on the great circle. The great circle here right now is the equator. Okay. So, I can directly measure the angle on the great circle, as already we have agreed upon. Okay. So, to measure the angle, it will be the graduation already we know it is at 10-degree interval. Okay. So, you have 10, 20, 30, 40, 50, 60. So, the angle between A and B is 60-degree. Okay. So, that is what is there. There is another two poles E and F. Okay. Again, fortunately they are falling on one great circle here. Okay. So, any this ruling which is connecting north and south, okay, that will be the great circle, and for latitude only the latitude connecting west and east will be great circle, the rest of them are small circles. So, I cannot measure the angle on the small circle, only on the great circle. Okay. So, in this case now it is again if you see the graduations here, okay, it is 10-degree, 20-degree. So, the angle between E and F poles is 20-degree. Okay. Another one C and D, okay, again you can measure 10, 20. So, angle between C and D is also 20-degree. Now, the problem starts. Okay. In this case now there are two poles A and B, but they are not falling on the great circle. Okay. So, in this case I cannot directly measure the angle like this. Okay. So, to measure the angle, what I will do, okay, I will go out of this slide show right now, okay, so that I can rotate it, rotate this particular, okay, and the rotation is done such that both the poles are on one particular great circle, let us say this one. Okay. So, both the poles should be on one single great circle. Okay. It cannot be on two different circles. Okay. So, for example, I have brought these two A and B on one great circle. So, this I will go to slide show again here. Okay. So, you can see this is this particular great circle I have chosen. Okay. And while rotating I saw that these two poles are falling on this particular great circle, okay, this one. Okay. So, now I can directly measure the angle between the two. So, it will be 10, 20, 30, 40. Okay. So, 40-degree is the angular the angle between the two poles which are A and B here. Okay. And you can then bring it back to the original position, there is no harm, because once we have measured the angle we know what is the angle between the two poles A and B. Okay. Now, how to find the trace of the planes? Okay. Again the same poles I am taking A and B, okay, and let us again go out of the show here. Okay. Now, if you remember and I have noted it down here also, that rotating the projected pole relative to wolf net till the pole fall on the equator, and then tracing the great circle which cuts the equator 90 degree from the pole. Okay. So, I am going to do that now. I will rotate this one such that the A comes on the equator here. Okay. So, A is now on the equator. I should have rotated the so now I am rotating the wolf net. Okay. Not able to rotate it. Okay. So, I will choose this one and I will rotate it. Okay. So, basically I want to tell you that this dark one is our equator. Okay. So, I will bring A on that one. Okay. So, this is my equatorial line on which I have brought the A. Okay. And now what I will do, I will count the 90 degree from here. So, it will be 10, 20, 30, 40, 50, 60, 70, 80 and 90, and the 90 I will plot the trace. Okay. So, to plot the trace I will go back to the slideshow. Okay. I will choose the pen here and then I will, so I will count 10, 20, 30, 40, 10, 20, 30, 40, 50, 60, 70, 80 and 90, and 90 whichever this great circle is coming, that is my trace. Okay. That I am tracing here. Okay. And then next I will bring the point pole B. Okay. So, next I am bringing the pole B by doing further rotation here. Sorry. Okay. And now I will plot this by going in the slideshow and taking this thing. Okay. Again 10, 20, 30, 40, 50, 60, 70, 80 and 90. So, this is the pole for B. Okay. Maybe if you want I can change the ink color here. So, for B I am plotting with blue color now. Okay. And then I will bring the back to the original position. Okay. So, these are our two trace of A and B. Okay. Coming back to the slideshow. Okay. So, now we want to plot using this idea that what will be the standard projection for cubic crystals. Okay. So, if you look at the standard 100 projection of cubic crystal, if I am plotting that, that means I am taking the unit cell like this and taking this as the 100 plane. Okay. So, normal is going and hitting the top pole. Okay, and it is projected. So, it is exactly at the center. Okay. So, once that is at the center, the other ones will be 001 and 010. Okay. So, that will be just 90 degree to this. Okay, 001 and 010, and obviously if there is a 90 degree relationship between 100 and 001, there is also a 90 degree relationship between 100 and 00 bar 1, which is just the opposite plane of 001. Okay. So, that will be plotted diametrically opposite to 001. So, any negative plane will be diametrically opposite on the wolf net or on the stereographic projection should be directly diametrically opposite to this one. Okay. So, similarly, I can for 0 1 0 this will be the negative 0 bar 1 0. Okay. Now, I want to find out the other type of planes which are basically 1 1 0 type. Okay. So, 1 1 0 planes have 45 degree relationship with 1 0 0 planes or 90 degree relationship. Okay. So, if I want to find any pole on the trace of this, so you can understand that this particular periphery of the stereographic projection is the trace of 1 0 0 plane. Okay. So, when I am taking the normal, okay, it is hitting the top pole. Okay. Then if I extend the planes, it will be the equatorial plane which is cutting the sphere at the equatorial plane itself. Okay. So, that will be the trace of this 1 0 0 plane. So, and we have already seen that the angle between the pole and its trace should be 90 degree, which you can see here also. So, it is 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. So, this is the trace of 1 0 0 plane. Okay. So, if I want to find any poles on the trace of this 1 0 0, okay, we have already discussed that if any pole is on the trace of a particular plane, okay, that should have the 90 degree relationship with the this pole. Okay. You can see already it here 1 0 0, if I take the dot product of between 1 0 0 and 0 0 1, okay, which you can easily do. 1 into 0 is 0, 0 into 0 is 0, 0 into 1 is 0. So, it is 0, cos theta is 0 or dot product is 0, that means it has a 90 degree relationship. You can see it here also. And in general, I can tell you if it is a 1 0 0 pole at the center and if it is, this is the trace of 1 0 0, any plane, okay, which is having a indexing like 0 k l. Okay. That means, the first index should be 0 and the remaining 2 can be any number, okay, that should fall on the trace of it, because if I take the dot product of this, 1 into 0 will be 0 plus 0 into k will be 0 plus 0 into L will be 0. So, dot product will be 0. Okay. So, if I want to find any 1 1 0 type of plane on this, okay, I know that any plane which has a dot product with 1 0 0 as 0, that will come on the this particular trace. Okay. So, for example, it should be, it can be 0 1 1 type, okay, it can be 0 bar 1 1 type, okay, and if 0 1 1 is there, it can, this will also be there, and if this is there, diametrically opposite, the negative of this will also be there. Okay. And you can also see that what will be the, so between 1 0 0 and 0 1 1, it has 90 degree relationship. We can also find out that what will be the relationship with 0 0 1 of this, for example 0 1 1. Okay. So, we know that cos theta is equal to 0 into 0 0 plus 1 into 0 0 plus 1 into 1 1 divided by under root of square of this plus square of this plus square of this. Okay. So, it will be under root 2 and similarly that will be under root 1. So, this is 1 upon under root 2, which is 45 degree. Okay. So, this will be somewhere here at 45 degree. Okay. And since this is a great circle, I can easily measure the angle directly on this. Okay. So, this is 10, 20, 30, 40, 45. Okay. So, this 0 1 1 should be coming somewhere here. Okay. You can also check this by doing a vector addition, okay, because this is almost at the center of these two. Okay. Since it is 45 degree here, it is here, from here also it is 45 degree, because 0 0 1 and 0 1 0 have 90 degree relationship. So, 10, 20, 30, 40 and 45. Okay. So, if I do a vector addition here, okay, so 0 plus 0 will be 0, 1 plus 0 will be 1, 0 plus 1 will be 1. So, vector addition proves that this should be 0 1 1. So, either you can find out from angle or you can find out from vector addition, okay, and there is another method to find out that what will be the pole at a particular location. Okay. So, if the 0 1 1 is here, just diametrically opposite will be, okay, again at 45 degree to both of these 10, 20, 30, 40, 45, and which is diametrically opposite here. Okay, if you can see here, it will be 0 bar 1 bar 1. Okay. Then 0 bar 1 1 will be, as I told you that there can be you can do a simple vector addition, 0 plus 0 will be 0, bar 1 plus 0 will be bar 1, 0 plus 1 will be 1. So, this particular one should come somewhere here at 45 degree, 10, 20, 30, 40, 45. Okay. So, like this I can plot the 110 planes. Now, some 110 plane will be at 45 degree. Okay. So, that will come between the 100 and 001 types. Okay. Okay. So, for example, between 001 and 100 again doing vector addition you will get a 101 plane, okay, and again at 45 degrees. So, 10, 20, 30, 40 somewhere here, similarly one here and one here. Okay. So, that is what will be there in animation also. So, this is 0 1 1, 0 1 bar 1, 0 bar 1 bar 1, 0 bar 1 1, just diametrically opposite negative of that. Then in between 100 and 010 you will have 110 at 45 degree. Between 100 and 0 bar 10 you have 1 bar 10 at 45 degree. Okay. Similarly 101 and 010 bar 1. Okay. Now, what these lines are? These are the trace of these particular poles. Okay. How I can find that? Suppose if I rotate this 0 1 bar 1 such that I bring it here. Okay. Everything else also will rotate. So, once I bring it here, what will be the trace of this 0 1 bar 1? It will be at 90 degree. So, 10, 20, 30, 40, 50, 60, 70, 80, 90, and 90 whatever great circle is going, which is this is straight line, that will be the trace of 0 1 bar 1. Similarly, I can find out the trace for 0 1 1, which will be like this, and once I have plotted I can bring it back to its original position. So, then you will have these two traces. So, this particular trace is for 0 1 1 plane and this particular trace is for 0 1 bar 1, and obviously true for 0 1 bar 1 1 also, negative also. Okay. So, these two are the traces of these two particular set of planes. Then I can find another trace which is for 110 plane here. Okay. As you can see, it is already at the equator. Okay. So, I can directly measure the 90 degree here. Okay. So, from here to here it is 45 degree, from here to here it is another 45 degree. So, 90 degree, and whichever great circle, okay, you can have a smaller graduations also here at 2 degree interval. So, whichever great circle is passing from here, that can be traced like this. Okay. You can also see whether if this particular pole is falling on the trace of this one, that means there should be a 90 degree relationship between these two poles, which you can easily find out by taking the dot product. So, 1 into 1 will be 1, plus 1 into minus 1 will be minus 1, and 0 into 0 will be 0. So, 1 minus 1 will again be 0, that means they have a 90 degree relationship between them. Okay. Similarly, for this one, so this trace also, this is the trace for 1 bar 10, and this is the trace for 110. Okay. Similarly, you can find out the trace for 10 bar 1 and 101 by rotating it and bringing 101 first on the equator and tracing whichever the circle is, and then bring it back to its original position. Okay. So, this is the two traces for these two planes. So, this is the trace for 10 bar 1 and this is the trace for 101. Okay. Now, how to find 111 planes here? Okay. So, 111 plane, one way is to find out that what is the angle between 100 and 111, okay, which you can easily find out by the cos theta relationship. Okay. The other way is that you can also find out from vector addition. Okay. It is somewhere very in between the 1 0 0 and 0 1 1. Okay. So, you can see that it is simply a vector addition of 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 1 is 1, this is 1 1 1. Okay. There is another way to find out that whether this is a 1 1 1 plane or not, okay, by knowing that whether it is falling on which trace. Okay. So, as you can see that 1 1 1 plane is falling on 3 traces here. Okay. We can take any 2 here. Okay. So, for example, one trace is this one, okay, this particular one. Okay. Let me change the color a little bit, so that it will be easily seen. Okay. So, one trace is this one. Okay. So, this is one trace here. Okay. This is for 1 0 1 1 0 bar 1 on which this 1 1 1 plane is coming. So, you can see this particular trace here on which 1 1 1 plane is coming. Okay. And there is another trace, this one, on which 1 1 1 plane is coming. Okay. And this trace is for 1 bar 1 0. Okay. So, now how I can use this information? Since I have told you if it is coming on the trace of a particular pole or plane, okay, then it should have a 90-degree relationship with that pole. So, 1 1 1 should have a 90-degree relationship with 1 bar 1 0 as well as 1 0 bar 1. Okay. So, if it has a 90-degree relationship, I can write two simultaneous equations here. Okay. So, using the dot product rule, okay, that means the, suppose I do not know the 1 1 1 right here right now. So, I am taking it as HKL. So, it will be 1 into H plus 0 into K plus it will be now minus 1 into L, okay. That should be 0. Similarly, I can write for 1 bar 1 0, 1 into H minus 1 into K plus 0 into L equal to 0. Okay. So, the first equation becomes H minus L equal to 0 and second equation becomes H minus K equal to 0. Okay. So, that means H is equal to L and also H is equal to K, that means H is equal to K is equal to L, that means all the 3 indexes are same. Okay. So, this should be sum of some type of 1 1 1 2 2 2 3 3 type of plane. Okay. So, since it is we can also do this vector addition and find out that this actually is 1 1 1 plane. Okay. And also you can ensure that whether this is a 1 1 1 plane, because this is also falling on this particular trace. Okay. So, the pole 1 1 1 should have 90-degree relationship with the 0 bar 1 1 bar 1 also. So, you can check it, 0 into 1 will be 0 plus 1 into 1, okay, plus minus 1 into 1, then that means it is minus 1. So, this is coming as 0. So, whatever indexing we have done is correct. Okay. So, like that I can do indexing of other planes also. Okay. So, now you can see that all these planes are indexed now. Okay. And now we are comparing it with a standard stereographic projection, which you may see in any book or something like that. Okay. So, this is how it will look. Okay. Only slight difference is there, that we have plotted here as 1 0 0 projection, whereas in this case it is a 0 0 1 projection, only that change is there. So, slightly the poles will change, but rest of the things will remain same. The angular relationship will be consistent in both the projections. Okay. Now, similarly, I can draw other standard stereographic projection also, for example, for 1 1 0 plane or 1 1 1 plane. In that case, when I am plotting 1 1 0, my unit cell will be such that the 1 1 0 it will, the unit cell will be like this. So, this is the 1 1 0 plane in that case. So, its normal is going and hitting the top pole. So, it is coming exactly at the center, and then the rest of the relationship you can easily find out. Okay. So, if the position is like this, okay, or maybe let us make it like this, okay, then you can see that the 1 0 0 planes are going and hitting the sphere at the equatorial plane itself. Okay, this one, this 1 0 0 are going towards in another direction, okay, which is kind of making 45 degree with this one. So, you can see that only one set of planes are directly going and hitting the sphere, whereas other 1 0 0 plane are coming at 45 degree with the 1 1 0. Okay. So, like that you can what we have done already, you can do it for 1 1 0, or if you are interested in 1 1 1, you can draw a standard stereographic projection of 1 1 1. Okay. And you can also show the same relationship in a standard unit stereographic triangle, okay, which is basically a triangle like this. Okay. So, you have 0 0 1, 1 0 1 and 1 1 1, okay, 1 0 0, 1 1 0 and 1 1 1. Okay. So, these are interchangeable, nothing to worry about here, and the other orientations you can show in between them. Okay. So, between any 1 1 0 and 1 1 type you will have okay, you can again do a vector addition. So, 1 plus 1 2, 1 plus 1 2 and 0 plus 1 1. So, 2 2 1. So, either it can be 2 2 1 type or 3 3 1 type or 3 3 2 type or and so on, depending upon what is the location of the pole, okay, whether it is closer to 1 1 1 or away from it, okay, or closer to 1 1 0. Similarly, between 1 0 0 and 1 1 0, it will, if you do a vector addition, it will be 2 1 plus 0 1 and 0 plus 0 0. Okay. So, exactly at the center it will be 2 1 0, or it can be multiple of that 3 1 0 or 3 2 0 and so on. Okay. So, this is a standard stereographic triangle, okay, and because of the symmetry of cubic crystal, whatever is there in this one triangle, that will be repeated in other triangles. Okay. So, you can depict the whole thing in one standard triangle also, instead of showing it in the complete stereographic projection space. Okay. With this, I hope you might have got some understanding of using stereographic projection. Okay. Now, we will use these ideas in plotting the pole figures. Okay. Thank you.